So these are the half reactions by adding H plus. Now why is it H plus? We are in acid solutions. All of the elements should balance, all right? Same number on each side and the total charge on each side. In this lesson, we are balancing redox reaction using the half reaction method in acid. It's going to look super complicated, but just follow with me through the steps and you'll see that you can do this yourself. So the first step is assigning oxidation numbers, and I've already done quite a few of these. The last one I'll do with you, oxygen is -2, so that's -8. And then the manganese must be +7. So is this redox? Well, yes. The manganese goes from +7 to +4, and then we've got the nitrogen going from +4 to +5. So this thing is redox. And so what we can do is write two half reactions. And the manganese, we'll just write that reaction. And you can tell that these don't balance. And there's no way to balance it. So these are the half reactions that I've written. And then let's do the next steps to balance these, because right now it looks like magic, right? We don't know how to balance this. So we're going to do it in acidic solution. All right, here's the first step. We're going to balance everything except the hydrogen and oxygen. So it looks like all we have is manganese and nitrogen, so that is already done. Now let's do the oxygen by adding water. Okay, so I'm going to need 2 oxygens in this first reaction, so I'll add 2 waters. That one's done. And then it looks like I need 1 water down here on the second reaction. Okay, so step 2 is done. Now let's do the hydrogens by adding H plus. Now why is it H plus? We are in acid solution, so we have plenty of H pluses to deal with. Okay, so I'll need 4 on the first reaction, so 4 H pluses, and then I'll need 2 on the bottom. Okay, so that is done. Now, notice that when we do chemical reactions, right, the number of atoms have to balance and also the charges. So we're going to need to balance the charges with electrons. So I've got +4 on the left, -1, so that's a +3. And then on the right, I have 0. So it looks like I need 3 electrons on that first reaction to balance the charges. Now the second reaction, I have 0 on the left, and I have, let's see, a +1 on the right. So I'll need 1 electron there. Okay, did I do that right? Let's see. Oh no, I'm sorry, I need to add it to the left. All right, just see if you're paying attention. So there's 1 electron on the left. All right, so we've done the balance the charges. Now, we still haven't balanced this reaction. So let me take you to the next step. I have rewritten the equations here. Now, the next step is to multiply by some factor so that those electrons are going to cancel out, because we cannot create or destroy electrons, right? So I've got 3 on the top, 1 on the bottom. So if I multiply everything on the bottom by a 3, they'll match. And I have to multiply everything, right? Kind of like Hess's law. All right, so that's step 4. And then step 5, what we're going to do is we're going to add these things up. Okay, square up your arrow, and some things will cancel. You'll notice that the electrons are going to cancel out. Some things will combine. Okay, so I'm going to write what's left over. So as far as hydrogens, I see 4 on the left and 6 on the right. So I'm going to put I'll have a net of 2 on the bottom. Okay, so there's 2 hydrogens there. That's done. And then let's see, does anything else cancel or combine? The waters, I've got 2 on the right and 3 on the left, so I'll have 1 water there. And I think everything else carries down. I've got the manganese components, and then don't forget the 3 NO2s and the 3 NO nitrates. Okay, and I think we're done. Do the charges all add up? On the left side, we have a -1. On the right side, we have a -1. I think we're done. So when you're finished with balancing these redox reactions, all of the elements should balance, right? Same number on each side, and the total charge on each side should balance. Now, what if we are not in acidic solution? If you're in basic, it's really the same. You follow the same steps, but at the end, you're going to do a little trick by adding hydroxides to take away those H pluses. Because remember, if we're in basic solution, we don't have H pluses, we have hydroxides. So it works the same, you just have one more step at the end.